And we are live. Can everybody hear me? Hope everybody's doing well today. I should start off with good morning, good afternoon, good evening. Welcome into Ecovate 3D. My name is Digital Dragon. I'm a 3D printing variety streamer here on Twitch. And we have relocated this morning from the Dragon Den over to Ecovate 3D for two reasons. One, I need to work on the Optimus P1 and it's big. And two, we've got the maker meetup that starts up at noon. So the easiest way is for me to come down here, stream some content from here because it's about a 45-minute drive in. So I got up, drove in here this morning, and we're getting things started off today. Is the audio a little bit better? I'm trying to moderate my volume. It's the same mic system, but I am finding that as I switch between the laptop and the setup at home, that the mic volume kind of goes different ways, and I haven't quite figured it out. Other than this is OBS on my MacBook, and at home I'm running OBS on Windows, and I know when I go and plug my Comica Boom XD receiver back in at home, it does weird wonky stuff to the audio back there. So, and yes, your stomach jolted when you heard about the print resume. Yes, that was not a good way to wake up. I was awake, I was laying in bed, and then I heard everything blip, and I was like, oh dear God. And I went running out into the living room where the Cheaty Tech's sitting, and the pit in my stomach was unreal because I had a feeling that, you know, you've got a 50-50 chance on whether it resumes right or not. What you didn't see on the camera was it had stopped mid-print, of course, when the power went down. The power came back up, and as soon as it came back up, it said, like, hey, do you want to resume? I said, yes, resume. So the temperatures didn't drop that much. It dropped the build plate, it homed the XY, and it moved back to the park position. And that's kind of what you see in the video, is it's back at the park position, and when it starts to resume, that's when it went haywire. And I was just like, no. Because that was about, let's see, around 7 o'clock this morning is when that happened. I started it around 5 o'clock before we started streaming last night. Excuse me. So it was 14 hours into a little bit over a 24-hour print. So yes. And I was teasing on the video yesterday about what that might be. That is the first print of my FDM Geo speaker system. So we will be building a set of FDM Geo speakers, as well as a set of FDM, or not a set, but a FDM 8S, which is the 8-inch subwoofer that'll go with it. Hey, Eagle the Dragon, how are you doing? I got coffee that I brewed here. This is some Black Rifle Coffee Company because I brought in my own cups and Keurig here. I do have Dunkin', and that does include Munchkins, of which a lot of them are pink sprinkles. So I don't know how that happened. I will tell you, I got a powdered sugar jelly-filled Munchkin this morning, which was crazy because out in Sanford, if we're lucky, we get chocolate glazed, like chocolate cake glazed Munchkin, standard Munchkin, and possibly like a blueberry or pumpkin at this point. They've got a very, very poor selection. But how's it going, everybody? So once again, today we're kind of starting off. I'm just sitting here trying to collect my thoughts. It was yeah, still a little bit disheveled after that massive print failure, or excuse me, not a print failure, the print resume failure this morning, and just thinking I've killed about half a kilogram of filament and 14 hours out of a print when that happens. So there will be another UPS in the house by the end of the day, so I can restart that print. And I chose to print that on the KDQ2 because it's a little bit bigger build volume. It's like 270 by 270 on the build plate, where the X1 carbons and the Centauri carbon are 256 by 256, and that would put it like literally edge to edge on one side of the bed. And I really don't like doing edge to edge if I can help it, just simply because it's a big chance for things to come off at the edge because of the temperature differential across the build plate. But yeah, so I'm going to switch over to the other camera. And like I said, we've got the Optimus P1 Pro over here. And this is the big boy that we've been working on. And funny enough, I'm playing nesting dolls with it. So I've got my Ender 5, which is, what's the name of this one? Mercury Rising. Mercury Rising. So Mercury Rising sitting over here. Let me go ahead and pull that out so that I can make some room. The person you may have just heard in the back was Waters. He just got into the store. So Mercury Rising is going to get a few replacement parts added back to it. You know, the ones that I took out of it to do the other 0G Mercury build, Magenta Rising. And we're gonna replace those parts, and it's gonna find a new home very shortly. But what you see here is the Optimus P1 Pro. This is a 600 by 600 by 1,000 millimeter tall print volume, roughly. We'll say 980 at the moment, just because we haven't tested the full print volume to see if we can get up to 1,000 millimeters or not. So far, we have removed the old style tool head. Okay, everything was using these aviation connectors. And this is literally just a volcano style hot end. Excuse me real fast, folks. Good morning, Timor. Welcome on in. Thank you for the resubscribe for 29 months. So it's a volcano style tool head. It had a thermal runaway event down here, so the whole lower half of this is new as far as the tool head goes. We have a titanium heat break in here, a nickel plated copper block, and a hardened steel volcano nozzle on here with a BL touch. Now, the one thing that we did notice is we've got the plate here, so the motor sits on the back side of the plate, which allows this portion of the hot end to go up underneath this front rail. What we've done is added the Blue Storm Terra tool head on here, which the LGX extruder is facing all the way to the front. So the motor hits this cross member before our Y-endstop makes contact. So we are going to have to create a little block right here. Luckily, there's a couple of mounting holes right here that we can leverage. And we'll create a little block that sticks out that hits that, triggers the end stop beforehand. Now you'll notice that there are two cables here, and in going to the Blue Storm Terra, which uses the Orange Storms Giga's toolhead board, That means that we're going to be going CAN bus. So we've got 2 aviation cables, 14-pin aviation cables that are no longer needed. So we've pulled those out. So that way what you're seeing is we've got the Y cable chain over here, and one cable that comes up through the cable chain and around that feeds the X motor. There's another cable that comes in that heads to the back and splits off because there is dual Y motors, one on each corner. We do have a cable chain up here at the top. This used to come around and exit out the left of the machine. I have now drilled holes and added it to the right-hand side of the machine because what we were finding is the cables for the CAN bus toolhead board. So this is a standard SB2209 CAN bus cable, or EBB 36, EBB 42, standard length cable. It's like 3 meters. Trying to run it through the cable chains, we were going to be at least 2 meters short. So by flipping the cable chain around, getting rid of the X cable chain completely, that will allow us to come out of the tool head, up through this cable chain to the back side of the printer, and then we drilled a hole here, added a grommet, and we'll be able to come out here with our wires and our PTFE tube, come straight down in through the back of the electronics box, because we do have several holes in the electronics box back here that we can come through. And then we'll be able to bring our CAN bus cables in. We'll grab power for CAN bus on our way, and the CAN bus cables will connect in here, and then our beacon cable will come all the way through and go into the USB. Now the beacon cable that we were given is a 5 meter long cable, so this is plenty long enough. We should be able to get there with this, and if I need to extend anything, it's just going to be the actual CAN bus wires themselves. The power wires will make it to the power side over here with no problem. The other thing that we yeeted was the thermistor. So the cables coming down here are going to the Z-axis, which are NEMA 23 stepper motors being driven by the main. These are Hanpos HPD 970 external stepper drivers like you would see on a CNC machine. And then there's also wires coming down here, these 2 independent wires. These are for the chamber heater. So there's a chamber heater that mounts to the bottom of the enclosure. So that means we need to measure chamber temperature. So we've got another big aviation cable. Like I said, it's a multi-pin aviation cable that they have clipped down to 3 wires. And this was routed around and literally made like 3 S loops in the front cross member and was mounted right in the front cross member. So we've yeeted that, and we're going to run a standard thermistor and probably hang it right back here in the back for the chamber heater. But the plan of attack today is to get these 2 cables run and hopefully get things started up and see if we can't do stepper buzz and validate that our motors are moving in the right direction. To do that, the cable chains that we have here are not standard cable chains like we normally use, right? As you saw, these things are pretty big, and they don't open. They open up, but they don't just like flip up like we normally have it. It literally, you have to pry them completely off and then snap them back on, which is kind of a pain in the butt. So what I'm going to do is do my best to fish these wires through, right, without getting them stuck in there. And then I've got to go from the tool head over for the one cable because this isn't going to fit through our grommet. And then we got to go from the side of the printer to the tool head for the beacon cable, because once again, we can't get the USB connector through the grommet. So that's kind of the way we're going to have to fish things through here. And let me go grab a stool real fast so that I can do this safely without standing on a high chair. And by high chair, I mean a bar stool. Okay, and once again, we're going to start at the front of the tool head here and start fishing our wire through to the side, and then we'll come in from that side with the other one. So yeah, I hope everybody's doing well. Hey, Down Under Maker, sorry I didn't see you pop in there. Just cruising by to say hi. Well, hello and welcome on in. We're trying to stay caffeinated. You may hear some thump thump music in the background. The store next door is weird. It's like a, what do you call it? It's a, like a smoothie bar and a gym all in one. It's kind of weird. What I am going to do, because I've got bare wire at the end here, is I'm just going to put a little bit of blue tape around this and see if that'll help keep it from catching as many things as I try and fish it through. But I hope everybody's doing well today. And Down Under Maker, how are you doing? It's kind of nighttime for you, isn't it? Is it nighttime? Should be. Yeah. So we'll see if that makes it a little bit easier to get multiple wires shoved through there. I'm going to do this in an attempt not to fall down or hurt myself in the process. Figures it hangs up right at the end over here. All right. Sure, because I've caught right at the end. Well, it's catching right on the end. Like if it wasn't connected, it would be fine, but it's catching right at the end. So you're gonna need a stool or something. A stool and possibly a pair of pliers. Yeah, needle nose preferably. So yeah, we've got the one cable going through. We'll pull that one through, pull it through the grommet, and then we'll start feeding the other one from the other side, which will be fun. While he's doing that, I might just go and put a little bit of tape on this other connector because that seemed to help it go through a little bit easier. So just so we don't keep catching all the connector pieces here, we'll add a little bit of tape around it. That, and it's going to help keep those wires themselves kind of from flopping around and give them a little bit of strain relief as we're trying to cram this through. It'll be okay, Waters. You should be able to get it. Yeah, I know. It'd be great if somebody put them back where they... Oh, I was going to make a comment, but I won't.
We are on live stream.
Oh, I know, but I can still heckle you on live stream, can I? Yeah. Yeah, the printer moves. It's on wheels. There we go. All right, so we got one end through.
How much you want over there?
Keep going. Keep going. Like I literally just want enough that we can come out, do some proper strain relief, and plug this in. Like there. And we'll be bringing the PTFE tube from the top here, and it's going to be able to come straight down. This is going to be a pass-through connector. It's going to go straight down into the top of the tool head, and we'll just kind of zip tie the things together. We'll have one more cable, which is I'm going to hand to Waters and have him start feeding in through the other direction. And this is where we might have to play with the cable chain a little bit. Wow. 2 cables through a cable chain and we're not having to fight with it. It'll be at the end that we always have to fight. Push it through, push it through. There we go, boom. All right, and just like that, we've got both cables through, so yay. And once again, this is for the beacon probe, and the beacon probe, we're gonna have to do some testing and some reading. So this is gonna have to. Oh, I gotta know. We'll get this connected down here into the beacon probe, but this is gonna come up. We'll join it in there. We'll throw a couple of zip ties on that, just to kind of keep that out of the way and together. The beacon probe can sense through glass. However, I don't know how big the glass can be. This base down here is, let me see if I can get the camera to go down there. So this base down here is glass, and it's a 4.5 millimeter glass plate sitting on top of an aluminum deck. I believe it's aluminum. So the main deck on here is the normal print surface. So if you got just the normal Optimus P1, not the Pro version, you would have no glass. You could add the glass later because this piece is right here. Basically, you've got a front and a rear piece that's just clamping down and holding the glass in place, okay? So we might have to yeet the glass to do some initial tests to make sure that the beacon doesn't drive into the glass and shatter a rather large piece of glass. But we'll try and get a couple of zip ties, like I said, up on these cables, and we'll have to figure out a secure point to actually tie the cables up to. You
could just use more of the squares.
Yeah, that's what I was thinking, is I would use the squares, but for now I just need to get these two semi together. And I'll have Waters cat us up a piece over here that we can use as the Y-endstop trigger point. I thought I did see some snips around here. There they are. Yeah, do you have some snips that'll work?
Yeah, they're right there. Because I need the steps that work.
Gotcha. All righty. So that's the nice thing about working out of a shop is you normally have tools and stuff everywhere. Now I do bring my flyaway kit that I bring to rep rap festivals. I do bring them down here as well, so that I always have access to the tools and I don't have to keep bugging theirs. And if you want to see something cool, this came off of
A Cheaty X Max
3. Okay, so this is off of a Cheedy X Max 3. You guys are gonna love this. I had a bad day because I had a power failure and things went south. This is a bad day.
And that's after I rescued.
And this was after he's worked on it and he managed to get this out. This was fully embedded in the tool head, so he managed to get enough out so that he could disassemble this from the tool head. And I think they're just gonna try and replace these components because the chances of getting this blob off without destroying the heater and thermistor are slim to none. So yeah. No, not new space techno side. I'm actually down at Ecovate 3D. So I come down here once a month and I host a maker meetup down here at Ecovate 3D. Mrs. Dragon is here, Eagle. That's how I get Duncan. She stopped and got the Duncan run for me so I can come in and get everything set up. Hey Jedi Spidey, how's it going? What are you pushing on a rope? So what we were doing is we had to move the CAN bus cable from this end through to the backside and then coming from the backside around in for the beacon cable because the CAN bus end won't fit through the hole that I drilled for the grommet because I'm trying to keep the hole fairly small because this is a heated chamber printer. And same thing for the other way around. One end of the cable is going to be too big to fish through. Yeah, yikes on that hot end. Watching from the shop. Nice, Jedi Spidey. Hopefully soon. We're in conversations right now. We're stuck waiting on zoning approval. Once we get zoning approval, then we will have a,
That's how much I've taken off.
yeah, so to give you an idea, this is how much filament he took off of that blob of death hot end just to get it out of the hot end enclosure. So that's kind of crazy. But yeah, we're looking into some shop space right now out in Sanford, and yeah, just waiting on zoning approval to go through before they'll let us sign the lease. So, which is a good thing. But yeah, hopefully everybody's doing well. And for those of you that are in the Raleigh, North Carolina area, right? We're down here at 6701 Glenwood Avenue, Suite 104. And this is, once again, Ecovate 3D. They are pretty much a full service 3D printing store. They've got, here, let's do the little spin around a bit. We've got yes for filaments, so we've got Polymaker, Bamboo, Recreuse, Cookie CAD, Epax 3D, who is a local company. This is Capricorn. Now Capricorn is going away. Well, no, let me rephrase that. Capricorn Tubes is sticking around. Capricorn is getting out of filament. And I just realized that we just had an ad that just ended. So I'm going to turn back over here. So we're down at Ecovate 3D this morning. We've got Polymaker. We got a Mrs. Dragon sighting. But we have Polymaker. Over here in the corner right here is Bamboo Lab, Recreuse, Cookie CAD, Epax 3D, which is a local company here in Raleigh, North Carolina. Morrisville, but Raleigh. Some Capricorn Tubes filament, which is, once again, they're getting out of the filament game. The open looking spools over here, this is all Green Gate recycled PETGs. We have some Epax up here, but this is some of the PETG and ABS and stuff that they carry. And then, let me move the printer back just a little bit. We're gonna need to do some work on the outside anyhow. And I'll turn you this way. And we have the, what I like to refer to as the wall of printers. So we have Idea Formers over here. These are belt printers. This is the Idea Former IR3V2. Really good belt printers, and they have one over here on display that they have. They have the Enraged Rabbit carrot feeder that I gave them mounted to it, trying to see if they can figure out how to do multicolor on a belt printer. Which, by the way, there is no slicer that supports multicolor printing on a belt printer. So
It's been fun.
it's been fun, exactly. We've got some Bamboo A1 Minis, some Bamboo A1 Mini combos, Centauri Carbons, and 85Xs. So if you're in the Raleigh area, you're looking for printers, they have printers. If you're out here and you want to see some printers in action, they've got an H2S, an H2D, some X1Cs, my Voron 2.4, and my Prusa Minis here. They do sell Prusa Minis as well. They've got the 85X, the Idea Former, pretty much everything but a Centauri Carbon that they sell, they have out on the floor. So, yeah. And if you're down here, come hang out and see this beast in person. As you'll see, we've got Send Cut Send. Send Cut Send is the one that cut the plate for me. I grabbed some stickers, and I can't remember if I put them in the backpack this morning or if they're still sitting at the house. But we're going to add a sticker or two for Luke's lab. We're going to add a sticker for Big Tree Tech and the Manta and Clipper, because this is now Clipperized printer instead of mainsail. And what else we got? Trying to think. Yeah. I'm going to put that closed for now, because what we need to do now is come over here and work in the electronics bay. So once again, we've got our 2 additional cables here that we're going to need to bring down and route in through the back. And you know what? I wonder, did I bring... Yeah, and I think I left the grommets at the house. I should probably put a grommet or 2 in here if we're going to route through here. But this one coming in is our CAN bus cable. Once again, we'll have to cut this a little bit shorter now, and then we're going to have to strip it back so that we can go to the power here and then keep our CAN bus cable coming all the way over here, which is really going to suck having to cut so much, not just cut so much wire, but cut so much of the sleeving off. It's just going to be fun. So I'm just trying to figure out how I want to route it. We can kind of come in low, but I like to stay up and away from the power as much as possible. So I'd really like to run it up here and then come back down for the CAN bus portion. But that means that we're doing something along the lines of that. And that means a lot of cable that gets exposed or pulled out of the sheathing to do that. Hey, Zombie, how's it going? So, Zombie, did you see the my post this morning about my print resume failure? I woke up to the morning to the subtle sounds of a couple of ups and everything else in the house doing the hard reset from a power blip. And the GDQ2, I set it up to, it came back up and I told it to resume the print, and it decidedly did not. So we had 14 hours into the FDM-GEO enclosure, the one that's a day print. a part of my soul died this morning when that happened. It was not a very good start to the day. It was not a good start to the day. Okay, so once again, we're going to be taking this particular wire. Yeah, I'm going to have to clip this end off and we'll recrimp it. And we're going to have to strip back a lot of this sheathing because once again, we're going to come in here. I'll bring the two wires down for power, and then the other two, my thinner wires, are going to continue up at the top and come down into the CAN bus for the board. So we'll just clip this off at the end and we'll re-terminate the CAN bus cables as we get down to the end there. So we'll do that. Let me grab my wire stripper stuff. I'll be doing a little bit of wiring this morning. This one and this one. As you can see though, I am trying to keep all of the original equipment, so somewhere down the road, if they decide to get rid of this printer or what have you, we can return it to stock and I can recover my Blue Storm Terra toolhead because, well, it's a pricey toolhead. But yeah, that part of my soul died when that happened this morning. I'm not sure if this is going to be enough to just strip that or if I'm going to have to do it by hand. Probably going to have to do it by hand to be safe. I'm going to do it old school. And then the 5-meter cable for the beacon probe, that was pre-terminated by Luke's lab. So we will we'll simply keep that to the length it is and curl it up in the enclosure. And if we have any issues with signaling to the beacon because of the extra length that's curled up there, we will just go ahead and we'll just go ahead and sorry, I'm brain farting and trying to figure out wires. We'll just re-terminate it. I do have USB connectors, so I can re-terminate. So what I'm doing is doing my best not to go all the way through the outer insulation, and you'll see me bending it to kind of crack through the rest of the insulation so that we can take the wires off without stressing the wires themselves as we're peeling this off. And once we expose this, the CAN bus wires, we're going to have to twist. You need at least 1 twist per inch on a CAN bus wire to keep from having signaling issues. And because we're stripping this out of the insulation that should have that twist built in, we're going to have to make sure that we twist this as we go. But the stealth changer parts are going good. We've got by the time I got here, the first set of Galileo 2 standalone parts were done. So that part of the fix, I'll say, has been completed. The as soon as I get home, clear the plate, I'll be able to print the other parts that we need to print, which will be like 20 minutes, 20, 30 minutes. And we'll have all the parts to do the 2 Galileo 2 standalone extruders so that we can get the tool heads put together. We'll still need to extend the power and thermistor wires a bit so that we can get them plugged into the board, but that won't be too bad. Come on, darn it. And when I'm done with this and getting all this insulation off, I will go back and double check and make sure that I haven't nicked any of these wires. Because the last thing we need is some wire shorts, because that will really stink as well. So you're saying put you on camera so people can see that you're stocking shelves and we can say that water's worked today?
Exactly. And then I can go lay down and, nap for the rest of the day.
Oh, man. That's the other nice thing about being down here and working out of Ecovate or any shop for that matter is there's people around that you can chat with and heckle while you're streaming as well. Like chatting with you, but that also means I have to sit here and read everything as well. So yeah, this is a pretty interesting setup from a overall system perspective. It's nothing different than any of the other printers that we build, right? Meaning it's a controller with some stepper drivers and motors. The only difference is just the scale. So this uses HG16 rails. I guess HG16, 16 millimeter rails. So they are chunky rails, right? And then we also have 16 millimeter ball screws for Z. And there are the thicker cable chains, but it's still all the same equipment, right? We got NEMA 17 motors for X and Y. We've got NEMA 23 motors for Z. So same concept, just bigger, like you would see on our CNC mills. And we've got 2 SSRs, one driving the bed and one driving the chamber heater. Just looking at this because it's getting a little bit harder and harder to strip the wire here. So I don't want to do a pigtail in here, but I might have to just because the wires themselves it's getting harder and harder to get the sheathing off, and I don't want to stress the wires trying to get the sheathing off. Yeah, it's a 600 by 600 by 1000 build volume. It's pretty hefty. It's a printer design from Sweden or Norway. It was about 8,000 euro new. The company that made it, Febtop, is no longer in business. And there is a company in the United States that will support them. And you can get parts from them. But once again, it's pretty much standard parts for like hot end and controller and stuff like that. It had an MKS Gen 1 or MKS Gen V1.4, I think, board that was in it, but it was running a custom Marlin firmware. And yeah, there we go. There's said board. And it was supposed to have TMC 2208s for X and Y. This one has a TMC 2208 for X, a 2209 for Y. Z was a pass-through to go to just move signal, step, and dir over to the external drivers, which are then powered directly from the power supply, 24 volts. And it looks like a DRV, was it? I can't remember what they are. The DRV 85 whatever. Like it's not a 4988, it's whatever the one right after it was for the extruder motor. So it's interesting choices for the hardware as far as the electronics go. And once again, like why it had a volcano style hot end with a 0.4 nozzle. So your build volume's 600, 1,000, and you put a 0.4 nozzle on it. Now, granted, it was an early 2000s printer as well. So, you know, aviation connectors to provide that industrial feel, so to speak. And yeah, just a premium price for what we look at today and go, well, it's kind of the same stuff that you'd put on an ender outside of the NEMA 23s and the, you know, just the size of the ball screws and linear rails. Yes, we're out of the layer today, Blue Chocolate Brew. How's it going, Zero? How's the Micron doing? I'm playing around with ant heads again because we're putting 4 ant heads in the stealth changer. So I've got, we've got 2 that are pretty much built. I just need to extend the thermistor and extruder, or no, the thermistor and hot end power. Getting close, and actually if I do run it low, we'll be there. So I may wind up just running this low so that we don't have to keep, trying to strip all this wire out. Keep that there. Bring this right around the back behind that. But yeah, so far the ant head installation is going good. I did print the wrong extruder parts because I'm going to do, I've got 2 Galileos and 2 orbiters. So the 2 orbiters, of course, are good to go. It's the 2 Galileos that I printed the wrong parts for, so I need to redo those. And once that's done, we can, where are we at here? Okay, once I get that done, then we'll have we'll have the 2 tool heads done. We did the modular docks last night, and we'll get the I was going to do the Galileo 2 ZXLs, And Steve Builds cautioned against that he said the folks in the Draft Shift Design Discord cautioned against that because it's a slower Z movement, which would be an issue when you're dealing with a tool changer because it gives you a lot more chance for oozing. So what I need to do is crimp ends to these, and then we will we'll put it right back into the same connector. So because we know that this is the correct connector because we had this all bench tested. So I need to pop like the green out, put the green in the same spot, then pop the yellow out, put the yellow back in the same spot. And what I'm going to do is just pop one of these out for right now, then I'll come back and pop the other one out afterwards. All right, give me 1 second here. Still fighting with the sinuses and allergies. Can always just convert a closet. Yeah, there you go. Let's see, what do we got? What do we got? Well, this is pretty good. It's like I said, it's 600 by 600 by 1,000 print volume, and it's not that big. I mean, it's big. You're not getting it through a standard door, but it's not that big. Micro printed 2 nights ago and then bent the DuPont pins going to the PZ and Y-endstop during homing. Oh, there was a homing override for it. Definitely like the ant head. I may change it up later and add the leaf cutter, or if Hart K makes an updated version, change at that time. Had a scenario come up where using the Micron on the go with a box turtle would have exactly. Okay. Stock 2.4Z is fine. Use some speedy power motors or something for higher speed. So, but high speed Z is loud, so not really worth it to me. So the issue here is I'm going to be putting the all-wheel drive gantry on. So with the addition of 4 speedy power motors or 4 Kraken motors, I thought having the additional torque of the Galileo 2 XL Z drives would help. But yeah, Steve was cautioning against that. And that's, once again, based on information from the Draft Shift Design folks. So I don't know if there's differences out there now, if people are looking at it of, oh, if you do the all-wheel drive Z, you might want to do that. I don't know. But right now what I was hearing is it might not be the best decision. Okay, this is that size. Okay, goes there. Now we'll pop out the other one and then we'll do this side. Stock 2.4Z has a ton of torque. It can lift the printer by the gantry. I doubt some extra weight would. Okay, cool. So in that case, I will reprint the parts that I just printed in the stuff, and we'll put the Galileo Z's over on the other 2.4 that's currently down here at Ecovate. The Trident is the Trident Iron Dragon is going to get a an update. I just really don't want to go low. I want to go high. But that printer is going to get a Jabberwocky, a box turtle, once again the all metal CNC gantry. Trident variant, of course. Aviation connectors sound really cool until you have to work with them. Then they're not so cool. They're just expensive.
Aviation cables sound really cool until you have to buy them.
Well, yeah, or work with them, because once again, the pinning these things out is not something that we're going to do at our houses. Dang it. Behind that wire. There we go. Okay, so that's coming up. We'll bring this power stuff down this way. So we'll be able to cut this. We'll cut it about right there. And these are going to go into Wagos, so I will put ferrules on them. I didn't have ferrules on them initially because we were just testing them on the bench, and I knew I was going to be cutting them to length and terminating them once we got down here. So you're going to reprint the red parts on the box turtle and rebuild it for your Trident? Okay, sounds good. Sounds good. Yeah, I'm the one for on my Trident. I'm going to rebuild it, and when we rebuild it, we'll enclose it and add some of the new. Yes.
Fair warning, that's very lemon.
It's very lemon.
Mm-hmm.
Okay, good. Waters is trying to make sure that I stay hydrated and we'll say healthy. So he has brought me some C1000 vitamin lemon. And yeah, it is very lemony. It is very lemony. We're going to see how that goes with coffee now, because we're going to chase that down with some coffee. Hey, Winnis, how's it going? I did see your message, Waters, and I checked, and I do not have any of those half moon clips. Yeah, and definitely let me know how that turns out when you do that rebuild. I'm going to double check the size. I know what the size would be in the kit that I have at home, but I just want to make sure it's the same size that I'm going to be looking for here. Okay, these are 20 gauge cables, which means they should be the white ones. Trim off that bit of excess that we had. Get the ground going. And so once again, my plan here is we're going to just leave the beacon wire long for right now, and we'll cut that down if we start having communication issues with the beacon. All right. So I really do like the, this is the sum line. Okay. It's the sum line wiring kits that I'm getting on Amazon. So the here's the tools, the wire strippers, and the crimpers for the ferrules. And this comes in the ferrule set. And the ferrule set that I've got comes with all different sizes and kinds of ferrules to include just the straight metal ones. And then the other kit that I have is, here we go. This is the Sumline crimping toolkit. God, come on, get the glare off of it. Right? It's got all kinds of ferrule sizes in it. And then the other one has the crimpers and is JST and DuPont. So, and you've got both the female and male DuPont and JSTs there. So I've got these for my kit. It works out really good to have at the shows. I normally don't have straight up wire in my flyaway kit because Evil Diesel normally has the wire, so I don't have to worry about wire. And then, yeah, I'm slowly built up to the point where I should be good without having any major issues at the shows. And if I do, then it's either an obscure connector or I physically broke something that we have to replace. Let me go ahead and take these out. These were my little jumpers that I put in place when we were bench testing. Get this one put back over in its spot. All right, so our black wire and red wire are going to come around through the back, right in there. Black wire goes to the ground side of things. Red wire goes to the power side of the equation. And we'll pull that back through. There we go. We'll have, once again, we've got plenty of slack on our USB cable. Like I could literally cut this way down, and we would be perfectly fine. I'm going to try and just run this all the way to the front of the case here. Oh, what did I catch on? Oh, there it is. Why did you go down there? Oofta. Trying to bring it above everything and all the way in the back so it's out of the way. And we're going to bring the entire cable as far forward as we can. Try and get around the back side of these aviation connectors, and I've dropped the cable now twice. All right. There we go. And what I'm going to do is I'm just going to bring this all the way forward, and I'll loop it down here and leave it in the front part of the case. And that way, once again, if I decide to go ahead and cut this shorter, which I just might, because then I can make another USB cable out of it. We'll cut it shorter. That just goes right there. Not into the Cat 5 cable loop, or the Cat 5 port. So there we go. So that's out of the way. We've got the 800 watt, 24 volt power supply. Everything in here is 24 volt powered, to include the NEMA 23 motors. There's our wireless thing. We will cut a front panel for this, and I'll have Waters measure this out, figure out the hole pattern, and cut it on their laser in the back. And then we can go ahead and mount it. And what we'll also do is, like here, because this wiring worries me, but like right here, we'll add a fan so that we can pull out air. So
You just do a little printed fan cover that goes on the outside, so you don't have to worry about the wiring.
I think we're ready to plug this thing in and make sure that we're still talking. So, would you like to do said honors? That one is yours.
The mini, yeah.
Whoops, sorry about that, folks. Just trying to get power to this thing. So actually it only needs the one, because the other one goes to the, we needed the other one, because that one's the
Heater.
Chamber heater. We could care less about the chamber heater right now. So the chamber heater is a mains chamber heater. It's 100% independent of everything else. So you would set that this way. We're off, but the emergency stop is open. So what we've got right now is there are fans going on the power supply, but nothing else has power. So we have an emergency stop and a power switch. So it goes through the emergency stop to the power switch, and then back over to our 24 volt, which then powers everything else. So with the emergency stop pressed in, or I thought it was. Oh, I guess it wasn't stop. So we've got the emergency stop pressed in. Yeah, the power supply still has power when the emergency stop's plugged in. That's why we're hearing the fan going. Sorry, I'm getting annoyed with the ring. And then we've got the power button. So we'll push the power switch and we should start hearing things coming on. We should see a light on the beacon, which I did see. So we're going to start getting things coming on. We've got power lights on in here, right? And what I'm going to do is I'm just going to move this kind of in the back, or right in the middle, because we need to do stepper buzz, right? So we need to do a stepper buzz and make sure that the X is moving in the right direction and the Y is moving in the right direction. If they're not, then we can swap them around. Luke's Lab's online. How's it going, Luke? You're actually just cosplaying? Now you cosplay as a machinist. Exactly, there you go. Yes, there you go. Good product placement, Waters. So the one thing that we found with the implementation here, Luke, is the old style hot end, if Waters will hand it to me. One uses these god-awful aviation connectors, so I'm glad that we are eating that. But this is the old style tool head. It's a typical, like, I literally bought a old Cheaty Tech extruder to replace this. This is plastic. It is a standard Volcano hot end with a 0.4 nozzle. So right now we've added a titanium heat break, nickel plated copper block, and a hardened steel nozzle. I think we put a 6 or an 8 on it. And it used a BL Touch, and the motor is at the back side of the plate. So this would actually sit under the X gantry rail. Putting the Blue Storm Terra on there, the LGX sits on the front side of the plate, and what would normally happen is this whole area here could go under this front cross member. So now the motor of the LGX hits the cross member before the Y-endstop triggers. So we're going to have to fabricate a piece right here to trigger the Y-endstop before we can really get this thing moving around today. Nozzles will be made today. Awesome, your blocks are done. And are those blocks for the Pika? Awesome. I am so looking forward to getting those. Giga makes a goofy choice for their setup. I chose the Ormstorm Giga, and we're not going to lose any print volume. We'll still have print volume, but it makes a perfect choice for this because we get the CHUBE hot end, we get the LGX extruders. So we've got an extruder that can push for days. We've got a hot end that can melt and get good volume out of it. And we've coupled that with a Gamma Master 1mm nozzle right now. And that's what we're going to start with. So we're going to move from a 0.4 Volcano nozzle to a CHUBE with a 1mm nozzle. And it should be able to push chonkers. Now, the question I'm going to have, and maybe you can answer this for me, Luke, while you're here. Let me get the bottom opened. So,
I did just cut the power off by accident.
Good job. Good job. It's okay. So this is 600 by 600 by 1,000 build volume. It's running NEMA 23 stepper motors for the Z, 16mm ball screws. It's got genuine high wind 16mm rails on Z, Y, and X. 15mm belts for X and Y. Dual NEMA 17 Y motors, single NEMA 17 X motor. And we just yeeted like 3 of these thick aviation cables because one of them, a 14-pin cable, was used for the chamber thermistor. Like, why would you go through the expense of a cable like this and cut almost all of them off? It makes 0 sense. Yeah. Right? So this was industrial feel to have industrial feel. Now this is an early 2000s printer. This is once again the Febtop from, well, it's a Febtop. They were, where were they from? I think Sweden or Norway is where they're from. And we currently have the glass bed on it. So the Optimus P1 did not have the enclosure, and it just had the metal plate down here. When you get the Pro, which is what this is, you get the enclosure, everything hangs on the side, and you get a 4.5mm thick glass plate. So my question to you, Luke, and anybody else out there is, will the beacon work through 4.5mm of glass, or are we going to wind up having to take the glass off and go straight to the metal plate? Oh yeah, it's way more complex. Now, what do you do with it? I'll go you one further. That's the original motherboard, the MKS Gen 1.4. It's supposed to have 2 TMC 2208s, one for X and one for Y, but somebody put a 2209 in here. I think this is an 885 whatever driver. And then the Z, which is right here, is a pass-through to 2 hand-pose HPD 970 like CNC style drivers. And this ran Marlin. And a TFT screen that the filament runout sensor actually ran through the screen, not the main board. It just made no sense. It had a customized Marlin installation that also allowed for a laser module to be used. And I told them that I would not work on this printer if they said that they wanted to ever put a laser in it. And they agreed with me, so you see me working on it. You think, okay, it should work through 6mm? Good. Is the bed steel or aluminum? Well, we shall see, because I think I just got handed a magnet. What is this? Oh, from Luke?
Yep.
Gotcha.
I just showed him your picture, Luke, of all the pretty copper.
Ooh, that's aluminum. Yeah, it's aluminum. So the plate underneath here is aluminum. Once again, it's NEMA 23 steppers on Z. It's coming out of, it's getting the direction and signal out of the one stepper driver on the MCU, but it goes to dual hand-posed 970s that are, of course, pulling power direct from the power supply. SU 1610 ball screws for Z, so it's great because you have the Z up here as you're trying to print, and you have a print fail or whatever, so you stop the print, and the bed drops the entire way and back powers the electronics the entire way down. It's awesome.
Oh, super great with a 0.4 nozzle.
Oh yeah.
On this print volume. Great plan.
So the aluminum is less responsive, but yeah, we'll find out anyways. So I need to bring up a Chrome window and see if I can't get logged into the printer. And what did I make this? I made this Optimus P1 local. Microsteps in section stepper Z must be specified. Okay. So we need to specify some stepper stuff. Let me, do I have a, okay, why is the mic not, okay, give me 1 second. Hey, we have this scene and you can hear me now, right? Awesome. Thank you. Thank you for that. Yeah, Inception. Oh, yeah. That drives me. I'm sorry. That hurts my eyes. That hurts my eyes. What the? All right. What is going on? Where is the? That's what I get for having multiple windows open. Okay. Hopefully you guys are not like seeing just craziness. So X and Y are moving backwards, which means Z's probably going to move backwards. Now Z should be all the way down at the bottom, so we may hear some weirdness when we do Z. But the Z's are being driven at the same time, so we don't have to worry about a Z tilt adjust issue. Okay, I think the Z's are going in the right direction. You saw me reach down and put my hand there because once again, the Z's are 1610 ball screws, which means the lead or one full revolution moves the bed 10 millimeters. With the stepper or stepper buzz, it moves a 1 millimeter or a couple of millimeter increment. So I was hearing the motors move. I had to put my finger down there to actually feel them move, and it was turning left, then back to the right, which means as it turns left, it's going to raise the bed, and right, it's going to lower the bed based on the screws, which you probably can't see, but the screws are OBS. Bench. Okay, so the screws are angled like this. So when it goes to the left, the screw is going to move to the left, which is going to raise the bed up. And then when it goes to the right, it's going to lower the bed down. Rotation distance isn't optimized, so the movement is minuscule, aka hard to tell just by looking. Yes. So, like I said, the X and the Y motion we know are going in the wrong direction. I think the Z is going in the right direction. And once again, from the Marlin settings that we had captured, we're trying to guesstimate on how to make things move in clipper right, if that makes sense. So I looked at, okay, how do ball screws get done in clipper? It's a 10 millimeter lead. So we'll look at the configurations for clipper here now for that Z motor, because we're going to have to come in here and change the direction of X and Y motors. So the step direction, we're going to change that one. The Y step direction, we'll change that one by adding the exclamation point. And then Z, it's currently set up, we just picked 16 microsteps. It needs to have a microsteps in there, even though it's configured on the dip switch. Rotation distance is 10, because once again, it's a 10 millimeter ball screw. The lead, it's a 1610. 16 denotes the diameter of the ball screw. 10 denotes the lead of the ball screw, which is one rotation is 10 millimeters. Steps per rotation, I do believe this is the NEMA 23s are 1.8. Give me 1 second, folks. Ow. Hey, Ava. I am live streaming, by the way. Okay. And then yeah, I do believe we have max.
Somebody wants a nice home server. There you go.
Position max, position min, homing speed, second homing speed. We commented out the TMC 2209. The extruder section is copy and paste from the configuration for Luke's lab. So I think
Oh, this one did the ejecto.
I think we're going to be good there.
Those, I ran out of switches since I planned on using the extras from these specifically.
So I think we're good. I should be able to home the X. Like I said, I cannot functionally home the Y at this point just because well, I can home the Y, but I'm going to have to physically stop it before it rams the tool head into this bar, because the back of the motor on the old one, the motor was coming from the back side of the plate. Now we have the motor at the front. It will hit and collide with the cross member here. But let me go ahead. I'm going to home X, which we should see it move over here and do the homing cycle. And it's going in the opposite direction. Y. We just checked. Okay. So let me check that again. We changed the direction of X because it was going in the wrong direction. Position in stop is 600 max. Does it go? It goes positive, negative for the first stepper buzz, doesn't it? So they were going in the right direction, and I'm just an idiot. Or I'm not going to say that. It's been a rough day in 3D printing for Digital Dragon. If you saw my post earlier, it was a sad day. And X is still going the wrong direction. What is going on? We just... Seriously, what is going on? I just changed the direction. All right, now I'm confused. Wrong screen again. OBS. So, did you save and restart? I thought I did. I thought I had. So I will go back in and we will do the save and restart. So let me pop back in here. Machine, printer config. I'm going to do a save. I just did a save and restart. Okay, going the wrong direction. Gotcha. Come in here, printer config. We'll add the change of direction. Change of direction. Save and restart. Everything is restarted. Home X. And X still goes to the left. So now there's some wonkiness in the system. So I did change the direction. X and Y. Let's look over the full display so you guys can see what I was looking at here. We changed the direction on X and Y in the printer config. And we did that by adding a exclamation mark there next to this. To the step pen, not the dur pen, because once again, apparently I have not had enough coffee yet today. And I just need you guys to look at it to prove how much of an idiot I was this morning. Really, I just have not had coffee. So let's try this again. X should go to the right this time. Hey, we changed the direction instead of the step and it works right. And homing speed is set slow for right now because I need to make sure that everything's working and nothing's hitting and damaging. All right, so X is homing good. So that's not an issue. Y should start moving to the front. Nope. So Y needs to change direction. So we'll come back here and change the direction again on Y by doing the actual direction pin and not the step pin. And everything just rebooted. X, Y, and Y starts coming forward. Once again, I'm going to have to tap it before it gets here or we will jam the tool head into the gantry. All right, now I do want to come in here because do we have a retract distance of 5? I didn't see it retract. Homing speed is currently set to 25. We'll make it a little bit more robust. And I do want it to back off a little bit more. Save and restart. We'll move this over. Okay, so we're going to home X. A little bit faster, so that's good. We're going to home Y. So it's homing, it's backing off, and then it's coming back to the end-stop position. Or pretty darn close to it. So let's see, where else are we at? Let me come back over here to the bench side view for you guys. Now the Z, we're going to have to, we haven't configured beacon yet. So we have to configure beacon before the Z will be functional. So which one of my windows do I need to look at? I think this is the right one. Yeah, post-installation checklist. Beacon calibration. We have to perform the initial beacon setup, run multiple probe accuracy tests, verify standard deviation is below 0.020 millimeters, generate and save mesh, test Z offset consistency. Okay, what I think I'm going to do first is I'm going to PID tune the hot end while we're sitting here. Yeah, how am I going to say this? I'm going to do the beacon probe stuff off screen because I'll admit it. I'm scared of breaking the glass.
He's going to break the glass.
I'm afraid of breaking the glass. And as we talked about with Luke, the the concern will be that we
The aluminum.
words on stream are
less-
hard sometimes. The aluminum is less sensitive, and we have realized that it's a aluminum bed because a magnet does not stick to it. So I do know that this should have good God, is nothing on here steel? Like literally, nothing on this thing. All right, yes. I validated that the magnet's good because it sticks to the linear rail. But beyond that, yeah, all of the structure here is aluminum. So it's a thick aluminum plate. I mean, it's 1/8 of an inch, maybe even like 4 mil thick aluminum sheet that's been rolled over and formed, but it has a 4 millimeter or 4.5 millimeter piece of glass sitting on top of it. So that's going to be the issue. And what I'm trying to do is just roll into the documentation. We're getting temperature, we're getting stepper moving in the right direction. We haven't tested Z, but I will test Z here in a little bit. Stepper motor check, we did that. Things are moving in the right direction, I think. End stops are working so far. We can't do Z because I have to do the beacon thing. Where is, we checked X and Y homing. That's going in the right direction. We'll worry about bed locating later. Can we, oh wait, PID tuning. Bed and hot end. PID tune, heated bed. We'll do that a little bit later. I'm going to do the hot end while we're sitting here. We'll PID calibrate to 245 because why not?
Just a heads up.
Yeah. So we're going to start heating up the tool head. Oh yeah. And tool head temp's going up, so that's good. I do have, like I said, a 1 millimeter nozzle on there. It has not been hot tightened yet. So once we get the PID tune done, what I'll do is heat it up to 285, let it soak there for a little bit, and then I will tighten the nozzle on there. Yeah, don't use a diamond nozzle. No, this has a Gamma Master 1 millimeter nozzle on it. I do have 1.2 and 1.4 nozzles, but I mean, that's pretty much like, I mean, it's a good thing it's a CHUBE. It's got what, a 35 millimeter melt zone. So running a 1.4 nozzle through it should still work. We should still be able to melt plastic and put stuff down. Well, with the diamond nozzle on it, we'll cut the glass. And actually, my fear is that the beacon does not trigger, and I drive that nozzle into the glass and shatter the glass because it's, like I said, it's 4.5 millimeter thick glass. So we may just be on the safe. I don't know. We'll try it. I'm going to have my hand on that big emergency stop button right there. And if it looks like it's not stopping and that nozzle hits, I'm going to emergency stop it real fast. And then we'll let the bed drop down because, once again, it's ball screws. The bed's going to drop. There's no brakes on these NEMA 23s. And the X and Y end stops work. The X end stop triggered straight. And yes, the E-stop does work. Guarantee the E-stop works.
Luke wired it.
Yeah, I wired it. I've wired it and I've validated it numerous times on the bench and on the printer. The E-stop works. Yeah, if it looks like we're going to, like the end stop is going to drive in before, or the end stop. If it looks like the nozzle is going to hit before beacon, or it does hit before beacon fully triggers, then we'll let the plate drop down. You know, we'll e-stop it. We'll let the plate drop, or the build thing drop, and then we'll remove the screws and we'll remove the glass and we'll probe directly off the plate. It's a yeah, it's a smooth aluminum, so at most, I don't know, maybe we know a guy who could get us a 600 by 600 magnet and a 600 by 600 PEI sheet. I don't know. We might know a guy. He might share a name with me.
He might own the hot end. And
Yeah, he might own the hot end that's sitting here called the Blue Storm Terra and the CHUBE. So yeah. But set an allowable negative Z in the config, and when the bed gets within a few inches, use a metal tool to trigger the beacon for the Z stop, then manually adjust the Z and do the status check on the Z stop. Yeah, that was also another thought, was just taking like a ruler and setting it on top of the glass and letting it trigger off the ruler and then work our way down and see if it triggers. But yeah, it's worrisome one way or the other. What, lost cell reception in the school building? Like, could the school be running a cell jammer because they don't want kids using their cell phones in the school? Yeah, I mean, I've got PEI sheets sitting around. I mean, it's a 3D printing store. I'm sure I can find something metal that will trigger. You don't have the money for that? Yeah, or it could just be, you know, brick walls. So, okay, so the PID tune may have finished. Let me flip over and check the status of that. Nope, almost. Looks like the last round of heat up, and then the PID tune will be done, and we will save an update, and then we'll run a PID tune on the bed. Now the bed is mains powered, which is fun. I have no idea what the wattage is because we'd have to look at the website, because I think we did look at the underside and it's like just plain orange silicone matte. So very nondescript. Something built to be an emergency shelter, something avoiding specific words. Yes. I understand where you're at, Blue Chockaroo. But yeah, it's been a fun couple of days of streaming. Like I said, as soon as I get home today, I'll clean the build plate and start the other print, which will be about a half hour, and we'll have the Galileo 2 standalone extruders with the Orbiter 2 bolt pattern printed out, so we'll be able to assemble the Galileo 2s and get those those tool heads installed, and then we'll have, all we need to do is extend the thermistor and the hot end wires on all 4 hot ends and route the wires, plug them in, and we'll be done with the tool heads. So we'll have 4 tool heads done. We'll have the docks for all 4 of them done, and those were assembled last night. We were going to do the Z motors, but I've been cautioned against doing the Z motors. That the original ones are fine. So at that point, yeah, the next step is taking panels off, dropping the gantry, and rebuilding the gantry. And yeah, we'll rebuild the gantry. We'll get that rehung. Get the wires run back down underneath the electronics. We'll put it on its side, and we'll wire up the Leviathan board and get that set up.
Are you running the heater? The PID tune.
I PID tuned the hot end, so the hot end PID tune's done. Sounds like excuses.
I could smell the electrical heater from up front.
Well,
so.
yeah. I mean, it's a fresh new hot end, so yeah. Sounds like excuses. No, it's not excuses. I'm just trying to figure out the order so that we can go in and actually do things. Because once I pull the printer off the bench, it stays on the workbench until it's done at this point because of everything that's going on. So, yeah. That's kind of where I was going at there. So we're going to save the config. We've got the PID tune done. I was going to say, I didn't hear the hot end fan going. Oh, wait, there is no hot end fan on this. There's no hot end cooling fan on this. The part cooling fans, yep, they work. They make noise. Now we need to PID tune the bed. And I'm not going to PID tune it to 100. I'm going to PID tune it to 80 because just going to 100 is slightly overkill for this particular printer right now. Yes, it's enclosed, and yes, we can go to 100, but I feel at most we're going to do PLA and PETG on this. I don't see us doing a large build volume ABS print that's going to take several days. Or at least, let me rephrase that, not without a whole building generator in place. I was 14 hours into a 24-hour print, and the power blipped at the house this morning. I attempted to do the power off resume because I heard the power blip, and I immediately ran to the printer and tried to do the power off resume, and that failed. So I have about a half a kilo of PETG print and half a day's worth of printing going into the garbage.
Battery backup next time?
Yeah, I will be stopping and buying an UPS on the way home tonight. Because one of the UPS that I have at the house, all the batteries are dead. Yeah, I'm still live. Folks, it's a little bit after 12. The store is technically open. Like I said, all I'm doing is PID tuning the bed now. And once that's done, I think we'll be done for the day. So I'm going to go ahead and get ready to head out. Yeah. Happy Saturday, everybody. And let me see if I can figure out somebody that I can potentially raid into. See who's up and running this morning. Bawana's getting ready to start. He's gaming. Rise of the Podcast is live from the Twin Cities Con. We got same old Shane. Let's jump over to Rise of Podcast in the Twin Cities Con as he's running around there. Everybody, you have a great day. We're going to snooze that ad so it does not start. Everybody have a great day. Hey, Captain Kern, welcome in. Sorry you missed everything. But everybody have a great day. And I'm going to see you guys next time. We'll be back streaming definitely Tuesday. Not sure if we'll stream before that. We'll see. Hey, Hutch's Makerspace. But thanks a lot. And expect more content out of this big printer. We will be continuing to work on it. And we'll be posting pictures and stuff like that later. But thanks all for being here. You guys have a great day. And join me as we raid over to Rise of the Podcast, and we'll see you next time. Bye, all. And for those of you that are watching on YouTube, thank you for sticking around. If you like the content that you see, be sure to hit that like button down below. And while you're down there, go ahead and subscribe to the channel and ring that bell to get notified of future videos. Speaking of future videos, YouTube's going to be suggesting one, well, that way, I think. Weird camera angles today. Thanks all. Have a great day.